Hello, and welcome to the second section of the SMLC course, An Intro to Python. In this section, I will be describing the basics of Python, starting from the small history of it, to variables and data types, and much more. In this section, I will be covering 6 basic topics. First, like I mentioned before, an introduction and a small history of Python. The second topic I will cover is variables and data types. The third topic will be loops and conditionals. Fourth will be list accession. Fifth will be additional comprehension of lists and functions on lists as well. And sixth, I will be going over functions and lambda expressions. Keep in mind that the Intro to Python lecture will give you the basics of what you need to tackle the SMLC course. But if you are confused or need other descriptions or help, the internet is a great place to look, because the introduction to Python is a common topic to learn. First, let's go over a quick introduction of what Python is. Python, as you can see here with the ever-famous logo, is a popular language created for simplicity and readability. Python was created with the goal of a complete outsider understanding to a certain extent exactly what is going on in the code by reading it. Python is also index, indent, and case sensitive, meaning that variables with different cases will be different, and you might receive an error if you indent too much. Now, the importance of Python cannot be understated. Of course, there are other programming languages like Java and C++, but Python has been extremely important because it is streamlined. And it is also good for data usage, visualization, as you can see in this graph, and science. Python, as seen in this machine learning course, has been used for AI and machine learning applications, and has been perhaps the most popular coding language with today's programmers. Also, as you will see later throughout this course, Python has a vast array of libraries and modules that you can use to enhance your experience. The second part of the Intro to Python lecture will be covering variables and data types. First, I'll quickly go over what a variable is. A variable is a container that stores information. Like in math, a variable can be any arbitrary value unless you have specifically assigned a value to it. First, let's understand the basic data types of variables and see how they can be used in coding. We have 4 basic data types, as seen with most other programming languages as well. First, Booleans. Booleans return true or false and are usually case sensitive as well, meaning that it returns a truth value and you must capitalize the T and the F in true and false. I will go over exactly how to use these data types and how exactly they look in code in the implementation section of this section. Next, we have integers. Integers, like in math, are regular numbers. However, what makes them special in Python is that there are no decimals whatsoever. And integers can also be positive or negative. Having no decimals differentiates it from our next data type, the float. The float is an integer with a decimal. And even a regular number, say 100.0, is still a float. While 100 itself is an integer, 100.0 becomes a float. And finally, strings. Strings are a line of text, usually, set off by single or double quotes. Strings are extremely important in printing, in sending messages to the user, in receiving messages from the user, and many other implementations. Strings are the most versatile data type because you can convert anything into a string, and you can usually convert a string into anything if you have the right string. Now this segues perfectly into the next section of this chapter, the data conversion functions. Now, obviously, sometimes, especially in functions like the input function, which I will get to in a minute, you don't have the ideal data type. Therefore, it is imperative that you learn these 4 data conversion functions so that you can use them at ease to make sure that your values and comprehension of variables does not create errors in your Python code. The first data conversion function is a Boolean, which turns a variable into a Boolean value. This will only work with strings because strings are the only types of variables that can hold a true or false text. Next is float. Floats can turn a variable into a float. This can work with strings or integers. Next, the string function turns any variable into a string. The string function, like I mentioned before, is the most versatile because you can actually use it on any data type. Finally, the integer function turns any variable into an integer. It cannot work with a string with letters, a Boolean, or a float with a non-zero decimal value. This means your float will most likely have to be 100.0. Now let's look at the applications of data conversion and why exactly it's so important in today's world. First, one of the most important building blocks of Python code is the input function, where you take input from the user. You use the input function, and in the parentheses, you usually put a prompt and get the input from the user. However, the input function by default is a string, so you have to use the float or the int data conversion functions to convert it into a data type of your choice. If you're answering a math problem and you need to check someone's work, you can't use a string, but rather an int. Or if you need to multiply, you might need to use a float. Now, how can you make sure that you're converting into the right data types and that your data types and variables are in the right type? Well, you can use the type function to determine the data type of any variable. Whenever you're in doubt, simply just type in the type function and input the variable name, and it will give you the type. Then you can use whatever data conversion function necessary to ensure that you have the correct data type. The third and final section of this small video will be the loops and conditional statements section of the intro. Loops and conditionals are heavily important to Python because it is the majority of your automation in the early stages. For the basics, a loop, like in real life, is a repeated piece of code, usually until a variable meets a condition or a certain amount of iterations. Take, for example, this flowchart, where until you reach an item, you cannot leave the loop. It's like habits, where you cannot stop a task until you have finished, or etc. Now this segues perfectly into our first type of loop, a while loop. Now a while loop specifically states that while a condition is happening, do an action. And usually in the while loop, you update the condition as well. A key thing to note is that until the condition is met, the while loop will keep repeating. That means it is imperative that you update the condition during the loop. Say I have a condition, x equals 100. My action might be to print the value of x. But if I don't change the value of x from 100 to something else, the loop will go on forever. That is why it's important to update your condition. If not, it'll bounce back errors and your code will just not be efficient. The next most important loop in Python is the for loop. The specific syntax is for a specific variable in range anything or a count, you do a repetitive action. A specific note about for loops that differentiates it from while loops is that the for loop is about count. It is about the amount of time something is done, not whether a certain condition is met. Therefore, this means that the condition will constantly update and the variable will automatically update. Take for example the range function, which is just one of the things that we use to update a variable. The range function cycles through the numbers from 0 to 1 less than the x value that you put in. If I put in 9, the range function will cycle between 0, 1, 2, 3, 4, 5, 6, 7, 8. The range function is one of the ways that we can definitively count the amount of times we do a for loop. but we can also use other examples as well, which I will get to in the implementation section. Finally, if-else statements. If-else statements are a basic type of conditions, where if a condition is met, an action happens. The other two bottom parts of the syntax, the elif and else blocks, are not necessary, but they're quite useful as well. For all for loops and while loops, keep in mind that the condition has to be a Boolean function. So it can be equality, but you have to make sure to use a double equal sign, because only then will you get a Boolean value out. It can be greater than, less than, and much more. Again, as I mentioned at the beginning of this lecture, the internet will be your friend here, because you can find specific conditions that suit your requirements, whether it be not equal to, or equal to in a certain instance. So that's the end of today's small lecture. We covered the intro of Python, variable and data types, and the basics of functions and conditional statements. If you have any questions or would like to see examples, please check the implementation section of the Intro to Python lecture. Thank you for listening, and good luck in your future machine learning endeavors.